scan period, input scan cycle. Now I'm going to summarize it here. What happens during the input scan? What happens there? If you understand this sketch, you will understand the operation of the P.L.C. That input scan is where it is getting information from the process. So the short explanation here, before I give the full explanation, is to get information from the process and create the input image file. That is a brief explanation of what happens there. How does it happen? Now, here in the input-output section, I told you got the 4 racks. Zero one, 0, 0, 0, 1, 0, 2, 0, 3. Each rack has got the 8 slots. 0, 1, 2, 3, 4, 5, 6, 7. All of them are like that. Right? 0, 1, 2, 3, 4, 5, 6, 7. All 4 racks look like that. In those racks, what can we have there? Either an input card or an output card. Okay? So, the way that the input scan works, it starts with rack 0, 0, slot 0. So it starts there. Rack 0, 0, slot 0. What does it do? It checks on input card. Now there are 2 possibilities. There can be an input card, there can be an output card, there can be no card. Right? Those are the 3 possibilities that can exist there. What happens? It checks for the input card. Then, if no card or an output card, it's right 16 zeros in the input image file. So if there is no card or an output card, it writes 16 zeros there. What happens if it finds a card? Then it's doing something else. It checks if there's an input card. If there's no card or an output card, it will write 16 zeros. If found, that means there is an input card. Inspect. All 16 terminals. So, if it finds an input card in that slot, it checks all 16 terminals. To do what? If there's power on the terminal, it writes a 1. If there's no power or no connection, it writes a 0. Write 1 if power is on. Write 0 if no power or no connection. Write a 0 if there is no power or no connection. What then? Then it checks the next slot until it has inspected. How many slots are there? 32 slots. So after that, repeat. Until all 32 slots was inspected. Right, let's just check what happens here in the input scan. Starts with rank 0, 0, slot 0. Check if there's an input card. If there's no card, it puts 16 zeros. Remember that sketch I gave you yesterday of what the input image file looked like? It puts 16 zeros in the first word. Then it checks the next slot until it finds an input card. If it finds an input card, it inspects the 16 terminals. Then it will put 0 or 1 into those 16 bits. Depending on if there's power, it puts a 1 there. If there's no power or no connection, it puts a 0 there. So, at the end, when it's done all 32, that 512 bits will be filled with zeros and ones. So it creates that input image file. You got it? Now when I talk about it, it sounds like a long time. But this takes about 2 or 3 milliseconds. That one's very fast. Okay? The important thing that you must realize, during that period, it works here. And let me get a piece of colored chalk. During the input scan, it is working here. it's working there. This part, the processor is not involved. It's just creating the input there. So it is working here. Here's the process. Here's the input-output section. It's working here. It's creating the input image file from the input cards, which is connected to the process. Okay? This is not involved. It's only creating that there. Then we come to the next part. This is the user program. This is the user program period or section. What this is what we are doing in the lab. It is this type of thing. So here are the steps, the logic. That is the logic that is here. We're going to come back to this again, how this is done. But here we will find some more other logic. The last one is always looking like this. We will talk about that later as well, at end. We don't have that end down in the lab. In the bigger PLCs, it always has an end line to say this is where the logic stops. So this is continuing until we get end. So during the user program period, it executes the logic. How does it do that? It gets the instruction from the user program. Then it will check the address and it will get the data from there or from there or from there. Then it makes the decision and it will write the result of the decision there or there. So, the short name, the short answer for the user program. The short answer there is it executes the logic. It executes the logic. But how does it do it? Step number one, get an instruction from where? From the user program memory. Two, it gets the instruction. It says, oh, this is a normally open or this is a normally closed and this is the address. So then it gets the data from where? The input image file or output image file, or variable data area, depending on the address. What do I mean depending on the address? If the address is starting with an I, it's going to get the information from here. If the address starts with an O, it's going to get the data from there. If the address starts with B3 or T4 or C5 or N7 or F8, it's going to get the data from there. What does it do then? It makes decisions. It says, okay, the instruction was normally open. The address was I. What is the data? It is a 0 or a 1. If it was normally open and the data was a 1, it says, okay, the decision is this thing must close, it must pass current on. What does it do with that decision? It is creating the output. It makes decisions and it determines the value of the output. And determine the output. So, it gets in instruction from here, get the data, and then it determines that output. That output address can start with O, or B3, or C5, or whatever. It cannot start with I. Doesn't make sense. The output is normally an O or some address in the variable data area. So what does it do then? Let me continue here. Number 4. It writes the result in the output image file or variable data area. Depending on what? Depending on the address. The address of that output. Right? And then it will repeat until it has completed all the runs. Repeat for all the runs. Repeat for all the runs. Now, just to come back to that processor sketch. This user program I said to you just now that the input scan is here. Input scan works there. So while it's doing the input scan, the CPU is not doing anything. When it's doing the user program, it is not seeing the inputs, it's not seeing the outputs. It's performing the logic just in the processor. If there's any change on input, it will not know about it. It just performs the logic from the input section. Then, the last part. So now we've dealt with this part, the user program. And this last part is the output scan. Now, remember what I said. Here in the racks and slots, there can be input cards or output cards. Right? The input scan was just looking for input cards. It ignored if there is an output card. It writes zeros in the input image file. What is this doing while it is executing the logic? It creates what? The output image file. It creates that output image file by writing the results in the output image file. It creates the output image file. Now, the last part, that output scan. I'm going to write the output scan here. Now, this is not an answer, but it is very similar to the input scan. The output scan. What does it do? The short answer is it transfers the output image file to the process. That is the short answer. It transfers the output image file to the process. How does it do it? Number one, like that. Start with rack 00, slot 0. Same as that. Start with rack 00, slot 0. But now, what is different? Here it checks for an input card. What is it doing here? Check for an output card. Now, what is totally different here now, if it doesn't find the output card, it just ignores it. It goes to the next slot. It's doing nothing. But if it finds one, if found, transfer, all 16 bits from the output image file to the card. And then just lastly, number 4, card applies. The result to the process. So, the output scan is working here. The output scan is working there. And when it's finished with the output scan, it starts with a new input scan. It is a process. It never stops. It continues doing it. This time here is very, very short. That time there is very, very short. This time will depend on how big is that logic. But it can do this a couple of thousand times per second. So this is microseconds, right? That is microseconds. That is microseconds. This can be a few microseconds or even a few milliseconds. But it is possible that everything happens in microseconds and that total program cycle is repeated at a very high speed of more than 1,000 times per second. That is possible. Depending on also what type of CPU you are using. If you're using a fast CPU like a quad processor with a clock running at 100 megahertz, then it can be quite a number of program cycles. When I talk about it, it sounds slow, but it is very, very fast. The questions here can be different. I can say, sketch the total program cycle and then explain the input scan, or explain the user program, or explain the output scan. Or I can say, sketch the total program cycle and give a short explanation of each period in the cycle. So if I ask for a full explanation of the input scan, I want this. A full explanation of the user program section. A full explanation of the output scan. Or a brief explanation of each one. Just that. Okay. This is the end of chapter 3. And I just want to draw your attention to a sketch in the book. Oh no, there's one more thing that we've got to look at. One more thing, and that's modes of operation. But in the book, on page 52, you find this sketch. You will never be asked to do it, but it's a nice sketch giving you a summary of the whole chapter. There is the 3 blocks of the P.L.C. There is the processor. There's the input-output section. So it is a sketch that shows you all the parts of this. There's one last paragraph in this chapter, and that is the different ways in which we can operate a P.L.C. And I want to do that together with the sketch of the P.L.C. That sketch. Let me repeat it here. Input-output section, processor, and programming device. And then I'm going to talk about modes of operation. Different ways of operation. The first one is program mode. What do we do in program mode? We design, modify the logic. Design and modify the logic. So in program mode, we are working here. That's program mode. We design and modify the logic and transfer it to the P.L.C. The second one is test mode. What do we do? That's what we're doing downstairs. Practical 2. We just did